I'm going to go over with you pretty much everything you need to know for the exam coming up next time for Unit 4. So first of all, you do still need to know the kinematic equations. So make sure you have the kinematic equations on your equation list. So this could be your equation. Now, one of the things I hope you're doing is keeping an equation list as you go. So you're just adding equations as we move through the school year, just adding them to your equation list. But for sure, you will need this delta x or delta y equals v plus v naught over 2 times time So these are the 4 kinematic equations. Make sure you know those. Now another thing that I really want you to know, and not only in terms of equations and so on, but conceptually and the vocabulary and all that, I want you to know Newton's laws of motion. And there's 3 of them: the law of inertia, the law of acceleration, and the law of interaction. Now I'm not going to write these sentences out, but the law of inertia says objects don't change their motion unless a force is applied to them, an outside force is applied to them. So if you have a baseball out in space and there are no outside forces acting on that baseball, whatever that baseball is doing, it's going to keep on doing it. If it's at rest, it will stay at rest. If it's in motion, it will stay in motion in a straight line, constant speed forever. But if it runs into something, or if there's a gravity field nearby, it will change its motion because there will be an outside force applied to it, and that outside force will cause it to accelerate. And acceleration is a change in motion. Now the law of acceleration says that the net force is equal to mass times acceleration. Most important equation in all of physics, right there. Now what is the net force? The net force is what I get when I sum all the forces acting on an object. That is equal to the net force, and that will be equal to mass times acceleration. And this is what we use when we apply that procedure that I was talking about. Newton's third law is the law of interaction. It says that if for every force on an object, there must be an equal and opposite force on another object somewhere. Okay, the classic example is when a bug hits the windshield of a truck, the bug applies an equal and opposite force to the truck as the truck applies to the bug. Of course, it seems like the force is a lot bigger on the bug because the interaction is catastrophic for the bug and merely annoying for the truck. But just because the results of those forces are different doesn't mean the magnitudes are different. The magnitudes of the force are the same, but they are in opposite direction. Okay? Every time. There is no exception to this that we've ever observed in nature. The net force on the universe is 0. Okay? So make sure you know those 3 laws. Then we did a couple of experiments. We said, hey, the force of gravity, also known as weight, is equal to the mass of the object in kilograms times g. And g we called the gravitational field. Okay, and on the Earth, G is equal to 9.8 newtons of force for every kilogram of mass. And in what direction, obviously, does gravity pull? Gravity pulls objects down. So sometimes I'll say weight, sometimes I'll go F sub G, but sometimes I'll go M times G. And that's a perfectly good way of expressing the weight of an object. The object's mass times how strong gravity is pulling on it. Maybe for kicks, I'd give you a problem on the moon where G is 1.6 newtons per kilogram. But I don't think I actually do that on this test. So this is a basic equation that you should add to your equation list. And you should know this is mass in kilogram, and this is gravitational field. If an object's in free fall, then that means that the force of gravity is the net force, so mg equals ma, and the masses cancel and say, oh, the acceleration is g. And g magically turns from newtons per kilogram, turns into meters per second squared. Not magically, it's just the definition of a newton is a kilogram meter per second squared. So if you divide it by kilograms, the kilograms will cancel. Then we drag things across the floor, and or across your tabletops actually, and we came up with an expression for the force of friction. The force of friction, if it's kinetic friction, will be equal to the kinetic coefficient of friction times the normal force. Okay? And the normal force is the perpendicular component of the interaction between two surfaces that are pressed together. If a crate is on the floor, gravity's pulling it down, but the floor is holding it up. So it's that holding up force, that pressing between the floor and the crate that is the normal force. Okay. Now, if you have the force of static friction, it's going to be less than or equal to mu substatic times the normal force. Now, usually this is going to be an equality. We'll say the force of static friction is equal to mu static times the normal force, but that, oh, and that's for you, Sarah, I'm sure. What you're solving for there is the maximum possible static friction force before it breaks loose and starts sliding. Okay? So this will probably always be an equal sign in most applications. But I'm trying to be, correct here. Okay, then you need to know the procedure. The procedure. Now I'm going to give you, go back and review your notes, but I'm going to give you the abbreviated version of this. 1. GFS. What does the GFS stand for? Given, find, and solve with a picture of the problem. With pick. Okay? So you use given, find, and solve with a picture of the problem. Step 2. Draw the FBD. What does FBD stand for? Free body diagram. That's where you look at the object of interest and draw all the outside forces acting on that object of interest. Step 3, decide which direction is X and Y. And in some problems, you only care about the X. Some problems, you care about only the Y. Some problems, you care about both. So, but you look at your free body diagram and you look at the X and Y directions, what forces are acting. And then in step 4, you look at your free body diagram and then you do this. Add up all the forces in the X direction and set it equal to MA in the X direction. I would write this, underline it, and then do the X direction work below it. And then do the same thing. Sum the forces in the Y direction equals MA in the Y direction. And do that work below that. Now, sometimes, like the elevator problem, you don't care about the X direction in the elevator problem, so you don't need to write it down. But, you only care about the forces that are acting in the Y direction. But you are going to construct an equation based on your free body diagram doing this. Okay, this is Newton's second law, just broken up into 2 different directions. Once you've done all of this, Step 5 is just solve for the unknown. Okay, now it can be mixed with kinematic problems. Like I could give you kinematic information, and probably what you're going to have to do is use this equation or this equation or this equation to solve for acceleration. And once you know the acceleration, you can use it in one of these questions to solve for one of the forces. Or perhaps you use these equations first to solve for the acceleration and then apply it to the kinematic equations to solve for what I'm trying to find. But everything that is going to be on the test is going to involve this. If you understand everything that I've just written down here and can do it, you will do very well on the test. I tell you what, this is one of those tests where some people will be done in 20 minutes and have it perfect, and other people will work on it like an hour and 20 minutes, and so study this, know what you're doing, and you're going to be in good shape. Now I'm holding the test in my hand right here. Look, it's a half sheet. Okay, I'm not sure. It's just a half sheet of paper. So I'm going to go through it problem by problem with you. So you may take notes. Problem 1 is a dragster. It's a dragster problem. So you pop the clutch and you accelerate forward. If you have a car accelerating or decelerating on the road, unless that car is being towed or somebody is pushing on it, what's the only force acting in the x direction? The force of friction. Okay? So don't add applied forces unless there is an applied force, unless somebody's pulling on it with a rope or pushing on it or something like that. So this one will involve friction, it'll involve acceleration, it will, so you got a dragster, it's going to accelerate, you're going to use the kinematic equations, and you're going to use the procedure. Problem number 2. Mary stands on a scale in an elevator that is at rest. It's an elevator problem. She'll be at rest in the elevator. She'll be moving with constant velocity in the elevator. She'll be accelerating in the elevator. Study the elevator problems. It's a very straightforward elevator kind of problem. Now I might change the unknown a little bit, but if you set up the problem using the procedure, that's just step 5. Solve for the unknown. It'll be easy. Problem number 3. Somebody is shoving a crate across the floor with a certain force, certain mass. It's a horizontal floor. Of course, maybe I'll give you the coefficient of friction. Maybe I'll want you to find it. But it's a crate being dragged across the floor. Problem number 4. This problem I threw at you to see if you can extend your thinking a little bit. We've got 2 people pushing on a crate moving across the floor. 2 different applied forces. Will that change how you do the problem? Not really. Draw the free body diagram, and now you'll have 2 applied forces instead of just 1. And that's okay. Okay? Problem number 3. Something falls out of a truck and slides to a stop. Slides to a stop. Hopefully you can find the acceleration, you can find the friction force, you can find the coefficient of friction, or whatever, based on what's given. I give you enough information to solve for everything you need. And problem number 6. It's not really a problem, more of a question. And what I would do is study Newton's 3 laws. know the names of the laws, inertia, acceleration, interaction, and know what they mean in a fundamental way. It's not a problem. It's more of a question. And that's the whole test. Good luck on it. That is all.